Good morning, everybody. It is 10 o'clock. So just want to go ahead and get started this morning. Just for a second, I'll stop sharing my screen. You know you're in the right place now, but I want you to get a chance just to see who you're going to be talking to this morning. My name is Sierra Orr. I'm with the City of Big Bear Lake Department of Water, and my associate, Lauren. Lauren, if you want to introduce yourself, say hi.
Hi guys, welcome. Thanks for joining us.
Some of you may have talked to Lauren in the past. She helps with all of our rain barrel and our irrigation and our toilet rebates and our turf buybacks and all of that stuff. So you guys may have met her before, and that might be why you're here on our webinar this morning. We also have with us Laura Allen. Laura Allen is one of the founders of the Greywater Action network. She's been doing innovative work in sustainability and water use conservation and landscaping for decades. We're really lucky to have her. We do want to give you just a couple of opening slides, give you an idea of the parameters for today if you are just joining us for the first time. And I know we have a few first-time attendees, so I will do that now. And so, as I mentioned, you are on the City of Big Bear Lake Water, Fire, and Plants Oh My WaterWise webinar Wednesday series. There we go. Today is technically our 6th scheduled webinar, but due to some technical errors, we rescheduled one of ours to later in the month. So today is our 5th full actual webinar that we are presenting this year. Laura is going to be talking us through how to design and build a laundry to landscape system. If you missed that first one this month with Orchid Black, we were able to reschedule that to August 25th. So that's just going to be next Wednesday on rain gardens and swales. And the way these were structured this summer is essentially that first Wednesday of each month is generally on native plants or something along those lines. And those are all with Orchid. The second Wednesday of each month is here with, sorry, I think I mixed up. The first one is with Orchid, that's right. The second one is with Douglas Kent on firescaping and firewise landscaping. And then the third one is with Laura on Greywater. So you still have a chance to sign up for that one. The first 5 DWP customers to register for each series and attend live get the opportunity to win free prizes. We're going to have amazing books from Laura and each of our presenters and books that they recommend. This is specifically geared towards our Big Bear Valley residents, property owners, business owners. So if you know anybody else who could benefit from this, please do invite them. We still have 4 additional sessions left, so it's not too late. You can just email conservation@bbldwp.com to get signed up, or follow us on Facebook. We always post the registration link there as well. In case you didn't hear it earlier, if you have any questions, please do use the Q&A panel or the chat. We'll be monitoring both. Any questions that Laura doesn't answer during the presentation, we'll be sure we get to at the end. But if she answers it and we just happen to hear her, we will try to type it in there as well, so you have that on record and you'll be able to see exactly what the answer is, even if you do get distracted or have to go to the bathroom or something along those lines. So with that, I'll go ahead and stop my screen sharing, and I'm going to let Laura get started so you guys can get to the meat of this.
Okay, so we're going to talk about laundry to landscape. And when I'm in the full presenter mode, I can't see any chat or anything. So if you guys could let me know if anybody is having trouble hearing or can't see the slides, anything like that. So thank you for coming and to learn about Greywater, which is a great way to conserve water and also have beautiful landscapes. So we're going to talk about one kind of Greywater system today. I'll start with a really brief overview for people who might have missed the first presentation. Then we'll go deeply into the laundry to landscape system. It's the easiest to install. It works for the most people. It doesn't need a permit. It's really a great place to start. And I'll go kind of step by step through construction, though of course you'll need more information, which we'll leave at the end if you want to really build this yourself or hire somebody. So I'll leave you with resources and some more places to learn if you're interested. So we'll jump right in. So other Greywater systems. Greywater is water coming from showers, sinks, and washing machines. There are many ways to use it. For shower systems, you do need a permit. There's gravity options. You can see in this picture, the water's flowing from the showers and baths going out into the landscape. Sometimes you need a pump if you have to go up a hill or if you have to cross a big area of hardscape. Sometimes you might filter grey water to go through a specialized drip irrigation system. So there's other options. Today, we're not going to talk about those. Those were in the first webinar. And in the resources I share with you, you can learn more about those. Today, we're just going to dive into one kind of system, which, as I mentioned, is really in most scenarios, the best place to start. And as you're thinking about greywater, I encourage you to just take a small step back and look at your overall property. And since you're in this whole series, you're probably already doing that. Just thinking about how can greywater be incorporated with other strategies to save water, to have ecologically productive landscapes that don't depend on tap water, on fresh water supplies. So maybe you're considering rainwater, and if so, where might you place your tank? Or a rain garden, where would be the best place to send the water from your gutters so it can soak into the ground using native plants? And then where can your greywater go, and how can these all work together? So it's good to think about these things not in a way that will be overwhelming and make you not take action and do anything, but just in a way to be a little strategic about where you might locate your various systems. And also, so greywater is irrigation water. So you always want to think about, well, what am I growing? And I encourage you to think about, if you're going to be doing any landscaping changes, how can you overall increase the value of your landscape? Value could be food production. It could be shade that's going to help cool your home. It could be growing habitat plants for native pollinators. It could be growing something beautiful that you enjoy looking at. So just thinking about the types of plants you're growing, and maybe this is a time to make some landscape changes, or maybe not. So we're going to talk about design. We're going to talk about kind of the components and then also the design. And design is really important with greywater if you're trying to save water, which I am assuming that all of you are. It's a really important time to be saving water and using our resources more wisely. So with a greywater system, you have to think about how you're going to be replacing irrigation. So I'm going to show you what not to do first, and then we'll learn what to do. So this is what not to do. This is in Southern California. It has to be irrigated. This is a green lawn in the summer, and they wanted a greywater system. So they put new fruit trees in the middle of their lawn and watered them with their laundry water. Nothing was technically wrong with their system, though they kept their green lawn. So they, sprinkled their lawn before the system, and then they kept on sprinkling their lawn after the greywater system. So the way they designed the system, it was impossible to actually save any water. With a better design, they could have located the fruit trees together in a cluster and then removed the lawn in that area, or just let the lawn go golden, or mulched over it, or done something where the lawn is not being irrigated, and then shut off some sprinkler heads. So then they would see water savings. So that's what you need to do, is turn off existing irrigation or stop watering portions of the landscape that you're now going to be watering with greywater, and then you save water. With an adequately designed system, you will save water. We did a study where we looked at water consumption from homes before they had their greywater and after. And you can see the red line is before and the black line is after. That's what you should see. That's what we want to see. It goes down. And so you're saving water. And that's what you guys will do if you put in a greywater system with a good design, or just an adequate design. So I already said what greywater is and what it's not. It's not toilets, it's not diaper wash water. Kitchen sinks are not considered greywater under current regulations in California, but it's all the other water sources. And so with any greywater system, and particularly with the laundry, you want to be mindful about what products you're putting into the water, because now this is going in to irrigate your landscape. So you want to avoid salts. Like a powdered laundry detergent is very high in salts, so you don't want to use any powdered detergents. You want to avoid boron or borate, or Mule Team 2020, that really high boron concentrated cleaner. Boron's non-toxic to people, so it's found in ecological products, but it is toxic to plants, so you don't want to use that. And then chlorine bleach is also not good, so you can always switch over to hydrogen peroxide bleach, and you can always turn off your system if on occasion you need to use something that's not good for your plants. It's easy to find these typically. You can get them at most major grocery stores. You can at least find one brand. There's a list up here, and there's kind of simple alternatives. Some people are getting into those little laundry strips, so you don't have any plastic waste, which is really nice. And those are also suitable for greywater. There's several brands. I don't believe they're available retail yet, but I know that a lot of people are ordering them and using those. And then at the retail stores, Ecos is a common brand. If there's a Trader Joe's nearby, if anyone goes there, they have a suitable detergent, and there's definitely more. So something that's really kind of unique about a simple gray water system like the Laundry to Landscape is the filtration happens in the landscape, and we use mulch. We use wood chips as a filter. It's not mulching your entire yard, but you're using a strategically placed wood chip basin. So you dig out some soil and you fill it with wood chips, and that's where the gray water flows through the wood chips. It's filtered and then it goes into the soil to water your plants. So it's a natural filter. It takes very little maintenance and it works very well. And so this is a key part of these gray water systems. So here is the system we're going to talk about today. It's called a Laundry to Landscape. It is from the washing machine. It doesn't require a permit. It doesn't alter your plumbing. So your home pretty much stays exactly the same. You just have to have one exit hole to get the pipe out, but everything else from your home is the same. So if you look at this picture, you see the washing machine. It has a pump in it. It pumps out the gray water from the machine. Usually it's pumping it right to your sewer or your septic connection. It's usually a utility sink or a standpipe. Maybe it's recessed a little bit in the wall behind your machine. That's going to the sewer. With a gray water system, you attach what's called a diverter valve. So it's a valve that can redirect the water either to the sewer or out to your gray water system. So you attach that directly to the appliance, which is your washing machine. So you haven't touched your plumbing at all. You don't need to be a plumber to do this. Any person that can do kind of basic home improvement projects is well equipped to install this kind of system. So you connect right to your washing machine itself. One side of the valve goes back to the sewer or septic, so nothing has changed. The other side now goes to your new gray water irrigation system. So if you can see in this picture, it's kind of an overview. The main line tubing is 1 inch, so it's a little bigger than a drip system, and the outlets are 1/2 inch. So everything's a little bit larger than a conventional drip system, but it is similar. It's using similar materials, just bigger, so you don't have clogging in the system. It goes out to your plants, to the basins, and as you're doing laundry, you're now watering these dedicated parts of your landscape. We'll talk about what kind of plants that are best for it, but you can see in the picture, it's watering the trees and the bushes, and it's just watering a couple of locations, because this is not a sprinkler system. It's not an extensive drip system. It's a gray water irrigation system, a simple one that's going to these different points to irrigate. The cost, it's usually a couple $100s in parts, between 1 and 2, maybe 300 if you're buying plants or anything to go into the system. And then if you hire someone, it's usually a 1 or 2 day project. So it's usually between like $700, maybe up to $2,500. It kind of depends. This picture is showing a very straightforward installation. You just pop out the exterior wall, go right to the plants. But some people, when they get home and look at or when you are home looking at your washer, you discover, oh, I actually have to go through the crawl space and then go all under my house. And then I have to cut some concrete to get past the sidewalk. And so these things can really add time and labor to the installation. So it could be really, couple hour project to maybe 2 day project. But overall, it's a relatively small home improvement project. So before you start this system, you need to have a well-functioning washing machine. So I like to call people's attention to a part of the machine that you may or may not be aware exists. It's called the pump filter. If you have a front-loading machine, the pump has a little filter around it that clogs up because it catches debris and things in your pockets, little wrappers or pennies or whatever gets into the washing machine. It catches that. And if the filter gets clogged, then the machine can't pump out the water. So that's really the most common reason a washing machine might not pump out the water. But if you put on a gray water system and you notice, oh, my machine's not working right, you might think, oh, it's because of my gray water system, but probably it's because the pump filter is not clean. So I always encourage you to clean this first before you start with gray water. And then if you ever have problems with the machine not pumping out the water, first check the pump filter, because that's usually the reason it's not pumping out the water. Top loading machines, I don't believe have them. At least I have never seen a top loading machine have a pump filter, but you can always look it up on your particular machine to find out. Okay, so now we're going to start from inside the home. You have your washing machine, you have the washer drain hose. It goes to that valve. It's that brass valve with the red handle. There's a loose fitting connection going into the sewer. So it's just the water's just dropping into the sewer connection, just like it did. The other side, there is an anti-siphon component, that little black thing. I'll talk more about that, but that just lets air flow into the system so you don't accidentally get a siphon action to happen and suck the water out of your machine. And then you go to your landscape. This picture, the home has a crawl space, so the pipe is going right through the floor and then it's going outside. That valve can be in any orientation. It can be sideways, it could even be upside down, it could be on the right or left side of the machine, that doesn't matter, but it must be above what we call the flood rim. So basically it should be as high as the top of your washing machine, not below. And the washer hose has to connect to the middle of the valve. So there's only one inlet on this valve and it's the middle. They're called ports. It's the middle port. So you can see in all these different pictures, even the one on the far left where the valve is turned sideways, the washer is always going into the middle port. I want to show you another one. So over here, this is a common kind of easy installation where on the sewer side, you attach another flexible hose and that just sticks into the sewer connection. So that can be easier than trying to pipe rigid pipe into that small hole. And then you can just use a second washer hose or some kind of 1-inch flexible hose like that. You can also adapt the aesthetics of the system. This home was a professional installation and they wanted it to really match the cabinetry in their laundry room. And so the installer did a custom little cabinet that was matching the wood and the stain and everything and cut the wall open and ran the pipes through the wall. So it was all hidden, though accessible. So you can open that little cabinet and turn the valve on or off. So definitely that's a possibility. Of course, that adds some cost, but you can really adapt the system to fit into the aesthetics that you want in your home. Stacked washers, they're usually a little bit trickier because there's not often room to put the valve. So there's ways to do it, but it might look like the valve being kind of in a recessed area. You might even need to create a little nook for it. But usually there's a place that you can put that valve. So there's different parts. This is all PVC pipe using threaded fittings, cutting with pipe. It's really, if you've done any type of irrigation work, put in a drip system. If you, again, do like small home improvement projects, you can definitely do this. And I'm not going to go over all the little parts, but I just want you to kind of see the quantity and the type that it is required to build the system. And then with the resources, if you want to go do this yourself or hire somebody, you can go to that and be familiar with the just the level of complexity of the system. So you're using Teflon tape over any threaded fittings that prevents leaks. You are connecting to your washer hose, getting the right adapter so that hose connects with the watertight seal right onto the valve. Then once you have all that connected up, you do have to get outside. If your washing machine is in a garage or an unfinished room and there's nothing, the walls are open, it's really easy to see where is the right spot to drill and go out. Or if you're going through the floor, there's usually not a lot of obstacles between the floor and the below, though of course that depends on your home. But if you have a finished wall, like a sheetrocked wall where there's outlets and all sorts of things in the wall that you can't see, like this picture shows, a sheetrocked finished wall is hiding pipes, electrical wires, maybe even gas lines. There's all sorts of things that could be in the wall. So this is the part where you really want to be sure that you're confident with drilling through your home. This is a part where some people feel like, well, I can do all the rest, but this part I really want to hire somebody to do for me, to drill that hole and get the pipe outside. So just be aware that a blank wall with sheetrock is not empty. There's lots of things behind it, and you want to make sure that you find a nice open space to send your pipe through, or go through the floor if you can. Okay, so the anti-siphon component, this is a little component. It's called an auto vent or an inline vent, and it just lets air flow into your system in case your washing machine, in case a siphon happens, like I mentioned before. No water comes out. It does make little gurgling sounds, so it's no louder than your machine itself, but it is a piece that you want to be able to see, because if it ever failed or broke, water could come out of this because there's water going through your system. So there's some parts to connect it all together. It could be inside, it could be outside. It does need freeze protection, so if you're in a freezing climate, it should be inside. It has to be at the high point. So if you are going through the floor, it's definitely going to be inside, but if you're going through the wall, then it could be either in or out. So you're using plastic pipe, like I mentioned. You cut it with, there's pipe cutters, a hacksaw. It's really easy to cut the pipe. You're gluing it, making sure everything is watertight as you move from inside to outside, because of course we don't want any drips or leaks or anything that could cause problems to your home. And then you're strapping that valve. It takes a little bit of torque to a little bit of effort to turn that handle. So you want the valve really secure. So when you turn it, when you turn your system on and off, your valve's not wiggling around. So you probably need to put some kind of backing of wood or you're attaching to a stud, something like that. And you're making sure your valve is secure. And labeling is very important. You need to make sure that whoever it is, you, your family, friends, house sitter, if they walk up to your machine, they can tell where the water's going and they can easily turn the system on or off based on if the water should be going outside or should not be. And so you can do a simple just label with an index card, handle here sewer, handle here gray water, that works. You can also take a photograph of the valve in both orientations and label that and print it out. There's lots of ways to do it, but just make sure it's really obvious where the water's going. There's also a code requirement. If you have above ground pipe, so if you're running through your crawl space, that pipe needs to be labeled. So someone working under the house could tell what is in that pipe. It has to be labeled caution, non-potable gray water, do not drink. Once you're in the ground, you don't need to be labeling the pipe anymore. So there is a resource if you want to do some design work that you can do a little sketch. So just at this point, it's a good time to think about how would it work in your home? How would you get the water out? You can do a little sketch as you're thinking about your system. I'm not going to do the sketch now, but on your own time you can, or I'm not going to take the time for you guys to sketch, but on your own time you can do that, thinking about how you would get your water outside. Okay, so now we are outside with our gray water, either through the crawl space or through the wall. And so now there's 3 things that we need to know to design the outside portion. We need to know how much gray water your home's producing. This is your irrigation water. Then we need to know what plants should we water. Most homes don't have enough gray water to water the entire landscape. And most homes have plants that aren't suitable for gray water. So I'm going to teach you about how to identify the right plants. And the last thing is how many of these plants. So we need to know how much water do these plants need and match that with gray water so we're adequately irrigating our landscape. So starting with the first one, how much gray water are you producing? So the person who does laundry in your home, if it's multiple people, I like to just put a little sticky note or something on the machine and have people tally. There's a fly who's coming around. And just tally up so you can see the average loads per week done in your home. Once you know that, you need to know how many gallons per load are done in your machine. The best way is to actually collect the gray water from one load of laundry and see how many gallons there are. But if you can't do that, you can use these numbers. Top loading machine, it's about 40 gallons, a front loading machine about 15 gallons, and a top efficient about 25 gallons. So just know what kind of machine you have. Top efficients, those are the kind of newer type of top loaders where if you open the lid, there's no agitator, it's just empty space inside. They're typically a little more efficient, or actually a lot more efficient than the old type of top loading machines with the agitator. And if you do have a better number, like if you were given that number when your machine was installed, you can use that. I found it's kind of difficult to get a number because these machines, the modern ones, they fill based on how much clothes you're doing. They weigh the clothes and then add water accordingly. And so the manufacturers typically don't tell you how many gallons per load. Though of course, that depends. So it can be just pretty easy especially if you have a front loader and not too much water is going to come out, to get some 5-gallon buckets and to actually collect the water as it's getting pumped out. It'll pump out in the wash after it washes and then after it rinses. If you have a top loader, a lot of water is going to come out, so it can be a bit harder to do that. So with that information, you also think about future changes. Let's say you have an old top loading machine, but you know that you want to get an efficient front loader. If you're going to do that in the near future, you should design your system based on the new water use of the new machine. If it's going to be like far in the future, then of course, just design for what you have right now. And so now we have the formula. You have your loads per week times your gallons per load, and you have your gallons per week of gray water. So this example, this home, they do 4 loads of laundry a week. Their machine puts out 25 gallons per load, and they have 100 gallons of gray water per week. So that is the irrigation water they have for their system. So you'll do the same for your home. This is just kind of the way to calculate it, and you can do this later. So the third thing, this number 3 up there, you also want to consider how many loads do you do in a day. This, we'll call it your daily maximum. So let's say you are the kind of home that does all the laundry on Saturday, every load. So whatever number you have, let's say you do the 4 loads, you do them all on Saturday. You have the same amount of gallons per week as your neighbor, but maybe your neighbor does laundry every other day or so. And they also do 4 loads a week, but they do it every other day. So their daily maximum is going to be smaller than yours if you're an all the laundry on a Saturday kind of household. This is not going to change how much irrigation water you have, but it is going to affect how big your basins are. And we'll get to that in a little bit. Okay, so now we're going to talk about which plants are a good choice for laundry to landscape. Trees are the best place to start. They're big, they need more water because of they're bigger. They're easy to keep happy with a greywater system. Fruit trees are always nice because then you get fruit. Shrubs and bushes are kind of your second choice. Then we get to your perennials and your big annuals. You're basically starting with your largest plants that want irrigation and working your way down to your smaller plants. Food crops are fine as long as the greywater doesn't touch the edible portion. So that means root vegetables are not allowed to be irrigated with greywater, but a fruit tree where the fruit's above the ground, or even a tomato plant where the fruit's above the ground, those are all suitable for irrigation with greywater. So these are not good options. Oops, let me get back. Lawns, they are not a good option for a simple greywater. They're not one plant, they're hundreds of plants. Per code, you're irrigating subsurface. So to irrigate a lawn, you have to actually rip out the lawn, put a specialized drip system underneath the grass, put it back on, then have a much more sophisticated system, expensive, higher maintenance system to irrigate, not the laundry to landscape system. So with laundry to landscape, just think about lawns are not an option. Drought established. So sometimes oak trees are kind of questionable. When you're in a drought like we are right now, some of these plants actually need irrigation that usually don't. But if it's under normal rainfall years, plants that are like an oak tree that doesn't really want summer irrigation would not be a good choice for being irrigated on a weekly basis. Then we have our small plants or plants in pots. These are not good choices. Sensitive plants, plants that maybe you just have trouble growing, they may not be a good choice. And then the root crops are not allowed. So let's say this is your backyard. What would you water? The trees. Look to your big plants, your trees, your bushes, kind of the perimeter of this yard would be a great choice. This would also be a great time to say, wow, that's a giant lawn that needs a lot of grass. I'm going to remove this whole lawn. Or maybe I want a very small patch because I have a dog or a little kid or some reason to keep a small patch of grass. Or maybe it could be converted to a more lower water use lawn and reduced in size. So this can be a good time too to look at your landscape with the lens of water and which plants can be irrigated with greywater and which can't, and do we really need to keep the ones that we can't water with greywater? Okay, so let's look at some examples. Are potted plants a good choice for laundry to landscape? Definitely not. The greywater would drip through the pot and then be right on that patio, surfacing and causing problems. Salad greens in a raised bed, not a good choice. Lots of little plants, edible parts touching the ground. Other plants in a raised bed. Raised beds are kind of a questionable one, and I do mention them because sometimes people, maybe they only irrigate a raised bed and they don't really have other kind of bigger plants. And so I do want to mention that raised beds are not, sometimes they can work, but it depends. They're usually not the best choice. So I won't go into detail on this, but if anyone is in the situation where you really are thinking a raised bed's the only thing you want to water, we can talk about it in the Q&A. Fruit trees, yes, great choice. Any kind of tree that wants to be watered, great choice. Edibles in the ground, tomatoes are good. They're a big plant, keeps the food up off the ground. You got to stake them up like you should be doing. So if you have other things that are bigger, that's a better choice, but it's definitely possible. But onions, carrots, and beets, these are root vegetables. These are not suitable for greywater. Okay, so now we know how much greywater you have and which are suitable plants. So now the last question before you can design your outside portion is, how many of these plants can you water? So we have to know how much water they require. So I'm going to start with some really general numbers just to give you a sense. Some people really have no sense of how much water plants need, and other people, for some of you, this might be really obvious. And then I'm going to give you a tool that you can use, an online tool that will do the calculations for you. So it can be a good resource to help you assess the water needs of your landscape. So these are really general requirements. If you have a smaller, medium-sized tree, it needs between 20 to 40 gallons per week. If it's a shrub, that's a less, like 10 to 20 gallons per week. And if it's drought tolerant, then it's even less, 2 to 6 gallons per week. Of course, super rough, but this is just going to give you in the ballpark. So let's say you're working with 100 gallons per week, and maybe before I said this, you might have thought, I'm going to water these 20 fruit trees I have. Now you know, actually, that's not enough to water 20 fruit trees, just to kind of get us in the ballpark range of what's possible. So now we'll get a little more precise. So peak irrigation, this is summer irrigation. Our plants need about a half a gallon per square foot per planted area a week. So what that means is you need to find the footprint of your plant. Like if it's a raspberry bed, you would multiply the length times the width, and then you would cut that number in half and you would get your gallons per week. So that raspberry bed, let's say it was 2 feet by 10 feet. So 2 times 10 is 20. So if it's a 20 square foot bed, we would take that number in half and we would get 10 gallons per week for that area. If it was not raspberries, if it was like a low water use native plant, then we would cut that number in half again and get our gallons per week. If it's a tree, so trees are not in a rectangle or a square. So with a tree, we calculate the circle, like the shadow of the tree. And so we just need to know the radius, the chunk to the edge of the branches, that's the radius of the tree. And then we use pi, which we'll just say it's 3. So at the area of a tree, we would do pi r squared. So 3 times the radius times the radius. So that's how you would calculate that. I'm going to show you a tool so you don't actually have to do this. So if this is feeling like, whoa, way too much information, I'm getting confused, that's okay, because I'm going to show you an online tool that does this for you. But if this feels like doable, you can easily go and look at your landscape and start to get a sense of how much water your plants are going to need. So the online tool, there's a website called puddlestompers.com, and it's a great resource for irrigation. There is an app called How Much Water. So you go to the apps and you click on How Much Water, and this is how you can find out how much to water your plants. The only kind of drawback is there's a whole bunch of cities in California that are available, but Big Bear Lake is not one of them. So I'm going to show you a comparable city. So this is based on what's called evapotranspiration rates, and you don't need to internalize this chart in any way. I just want to show you why I'm picking Sacramento as a comparable city. So Big Bear Lake, you can see the ET rates. This is how much is evaporating and transpiring out of the ground in each month. And the summer is the biggest one. So you can see these numbers, 7.6, 8.1, 7.4. These are inches. These are actually per month. This is how much water needs to be replaced for your plants during that time. If you look up at Sacramento, you can see that these numbers are really similar. And Sacramento is available on this app. So I just want to show you that it's a very similar climate in the summer in terms of how much irrigation the plants need. So with that, we go back to that app and we pick Sacramento. We pick weekly in July, because that's the time frame we're looking at. When do our plants need the most water? And we're doing it on a weekly basis. And we pick a moderate water use plant. So I was imagining like a fruit tree planted in the sun. Plants need more water if they're in the sun versus the shade, and some plants like fruit trees need more than a drought tolerant native plant, which would be a low water use plant. So there's a little drop down. So if you're watering native plants that are low water use, you would get a different little number in that wet plant. And then the last thing is, how big is your plant? So I said it's 5 feet wide, imagining a small fruit tree, backyard fruit tree. So I click calculate, and then I can see how much water that plant needs on average. This is historic numbers. So if you're in the middle of a heat wave, you're going to need to water more. So this is based on kind of typical historic over the last many years temperatures in this climate. 14 gallons per week. It's important to note that In the other months, like October can be very hot, it can be very dry, but plants don't need as much water because the days are shorter. So there's not as much sun, the plants are not as active during a shorter day time of year. So you can see that the same conditions, the plant only needs 6 gallons per week. So with this information, and I'm going to do multiple plants, but with this information, I can get a sense of how much water should I be directing to these different plants. 14 gallons in July is the most the plant will need, putting aside a massive heat wave. So I could water 14 gallons. I could also be a little less. The plants don't need their maximum all the time. So I want to be in the range around 14 gallons. I can see 6 gallons is enough for October, but it's not nearly enough for July. So I would say maybe between 10 to 14 would be the right amount to water that plant, because we usually don't change our laundry habits from October to July. So we're really trying to match to get a good overall best scenario for our plants. So this is where simple gray water systems can be challenging, because the way you design the irrigation is really unique, because you're matching how much gray water your home produces to the needs of your plants, knowing that your laundry patterns are not changing. So you're doing the best match you can. You're trying to maximize efficiency. Like I mentioned, you don't have to meet their peak need all year long. Maybe you can water a little more plants, and maybe in July you supplement once or twice a month just during that month. Or maybe you have enough water to meet their peak all year long. That's where you just have to make some choices when you're designing your system. And as always, you want to be shutting off your existing irrigation as you're replacing it with gray water. Maybe you can replace an entire zone, and that's really easy to shut off and also know how much you're saving because you knew how much you were watering that zone before, and now you can know it's being replaced. Or maybe you're just capping off sprinkler heads, or maybe you're just capping off emitters, or you can just put a ball valve in your irrigation line and turn off a section. So there's lots of ways to do it, but you do need to shut it off. And you don't want to take it out completely, because it's good if you already have it, it's good to have a backup if you do have that irrigation in place. So I'm not going to talk too much about this, but just so you know, this system is, you're doing laundry, it's going out to your plants. There's not really a lot of variation. You can have 2 zones. So in very kind of uncommon scenarios, some home, I shouldn't say uncommon, less common, a home maybe has a top loading machine, they do a lot of laundry, they have a lot of water going out, and they actually have too much for one area. So they want to have 2 areas, and you can do that. It's going to be manually controlled like this picture shows, but you're never going to have an automatic like multi-zone system as you do with a drip system with this type of longitudinal landscape. It's much kind of simpler, and you want to work within the limitations of the system. I'm going to talk about a couple of other limitations in the system, and then we'll kind of wrap up how you design this whole thing. So the longitudinal landscape system is connected to your washing machine. Your washing machine is it has a pump in it, but it's not a really robust pump. So it's not strong enough to go like up a hill. So if your landscape is uphill, like in the picture, there's a hill, any type of like really it's uphill, like you notice if you're walking up the hill, that is going to be unsuitable for longitudinal landscape. You will need a different kind of system that has a stronger pump. The pump can push water across a flat yard, no problem. 50 feet is a relatively kind of common safe distance to go. If you go too far across a flat yard, then it causes a lot of friction and it makes extra work on the pump. So you want to be irrigating plants within 50 feet. If you irrigate a bunch of plants and then you have a couple more farther than 50 feet, that should be fine because the pressure is being reduced along the way. Now, if your yard is downward sloping, there's no limitations on distance because gravity is actually moving the water. The challenge that you can encounter is it goes really fast down the hill, and if you're just kind of send a pipe straight down your hill, the water will rush down and you won't get water coming out the upper parts. It'll all go to the bottom. So to prevent that, you just serpentine, you kind of snake your tubing down the hill to slow the flow of water, and that way you can irrigate anywhere along that slope. The second limitation of the system is how many outlets you can have. So you might have a house that does a lot of laundry. Maybe they have a very efficient front loader, but they do like 100 loads a week, or I'm sure that's not a real situation, but let's just imagine someone does a lot of laundry. They could potentially irrigate many, many, many plants, but you're limited by each time the pump is pumping out the water, only a certain amount of water comes out. And so you can't go indefinitely to indefinite outlets because it's just the capacity of the machine. There's only so much water. If you have a top loading machine, you can go to about 15 locations, 15 outlets. You can definitely do less, but if you try to do more, then you're not going to get an even flow, or you might have trouble getting it to come out all of your outlets. If it's a top efficient, that number is reduced. A front loading machine, which puts out less water, you're looking at about 6, maybe 8 outlets. And if you have one of those really super duper efficient front loading machines, you're looking at about 4 outlets. So you can imagine, let's say you have a front loader, you can look at 6. You could do less, but maybe that's 6 trees, or maybe that's 6 outlets. And there's some plants that share the water because you have these basins, which I'll show you in a sec. But you're going to have 6 places that the water comes out. So you're going to be designing around that. So here are the basins that you make. So these basins are full of wood chips. That's the filter. If it's around a tree, it could be circular, it could be crescent. You're trying to be in what we call the drip line of the plant. That's where the branches end, and that's the best place to irrigate plants. You don't want to be too close, because if you're digging too close to the plant, you're going to damage important structural roots. But when you're out by the branches, any roots that you do encounter are just like pruning small, branches from the plant, which would not harm it. You could even be a little farther out from the drip line of the plant. The roots do extend past that, but just the drip line is a good visual of where you should be focusing your irrigation. So the tree, it could be circular, it could be kind of a half circle shaped, could be a trench. If you have like a row of bushes, then a trench is a really nice, just easy shape to do. As you can see in that row of bushes, there's a trench that would be full of wood chips, and you could have a couple of outlets in there. It could also be a pattern. You can see in the front, the smallest section, there's like a kind of a cross-shaped pattern of a basin, and you could have one outlet in the middle, and then the water would spread in that basin, and the roots of the plant could grow and access that water. So these are kind of the ways you would send the water out to the landscape. So there are a few limitations from the code that I want to mention. And the California Plumbing Code is what regulates greywater, and this system is exempt. It's exempt from a permit, but you have to be complying with basic health and safety guidelines. So you do need to know what the code requires, so your system will be legal. And the resources I'm going to share and kind of all the things I'm talking about would lead you to design a system that is. One of the requirements is what's called a setback. So setbacks are a distance you need to be away from buildings, property lines, creeks, etc., to prevent potential problems that your greywater could cause. So the building setback is 2 feet. So if you have plantings in front of a building, you would want to water on the side away from the building. You want to be at least 2 feet away from the building. A property line, the setback is 1.5 feet for the mulch basin system that I'm showing you. Though if your property is elevated above a neighbor's property, as water soaks down in the ground, it kind of makes this cone shape, so it goes down and out, especially like in clay soils, it can spread more. In sand, it does go fairly straight down. If you have clay soils and your property is elevated, you don't want your greywater to cone down and out and then actually surface onto a neighbor's property. So if you're in an elevated property, especially above like a sidewalk or a neighbor's patio or something, you need to make your setback bigger. This 1.5 feet is a minimum setback that's totally suitable for you have plants on your side of the fence and so does your neighbor, and it's all relatively flat. It's totally suitable. Just watch out if you're elevated above a neighbor, make this much bigger. Creeks and wells, you're 100 feet away. So if you have a creek or a well, you need to be good distance away from it, and then 3 feet above the groundwater table. And if anyone has questions about your site, we can do those at the end. So your piping around your landscape, your house you might have a 2nd-story washer, so you might be coming down the house, you might be going under a deck or stairs, you might be going around sidewalk, hardscape to get so you don't have to cut through it. There's lots of variations in how to get from washer to the yard. So your site might look different. Any pipe that you have is going to be painted. These pictures are showing construction pictures, but at the end, they should all get painted, usually the same color as your home. It kind of blends in, but maybe you want to call attention to your gray water pipe and do a bright color or something. It's totally up to you. You just need to paint it to protect the pipe from the sun. Hardscape, the picture in the lower left, that's a driveway, so it's got to be driven over. So they cut through that, put the pipe, and then patched it back up. You can do that. A sidewalk or something, something small, you can usually dig on both sides and then run under it. And then sometimes you might cut a little strip and go across. It really kind of depends on the scenario, but hardscape can be a little bit of a challenge. Crossing steps. You can usually just hug the pipe right across the steps, make sure it's secure, and that way it doesn't cause a tripping hazard. And we're getting to the end. Now we're just at the basin. So you've gotten there, picked your plants. Now you just have to make sure that you are digging your basins big enough to accommodate your water. So you'll remember I talked about estimating your weekly flow and then your daily maximum. So the daily maximum, this is where you need to consider, are you a household that does all the laundry on Saturday, or do you spread it out over the week? And you want to make your basins big enough to accommodate your daily maximum flow. If you have clay soils, your basins are going to be bigger than if you're working in sandy soils. Sandy soils, the water goes straight down. There's really never an issue with gray water ponding or running off because it just soaks away right away. But in clay soils, you have to accommodate slower draining water, and so your basins will be bigger. Clay, you want to have about a square foot per gallon. So if you were putting 10 gallons to this little tree on a daily basis or on your daily maximum, then you would have about a 10 square foot basin. The great thing about this is if you don't do it right, all you have to do is dig it bigger. And if you don't do it right, what you'll notice is, oh, I see gray water. When you're testing everything out, you put too much water in one spot, it's not draining, you see water, you need to make your basin bigger. So it's not hard to fix, and it doesn't really cause any problems if you undersize it. If you oversize it, it doesn't cause any problems at all, though you did some extra work, which is not a big deal usually. Okay, so I already mentioned that. And kind of lastly with these basins, you want to prevent the roots of your plant from getting too close and definitely not into the pipe, because they will grow up, they will grow to the water. They'll, as the water is coming into the basin, the roots are going to grow to that area. If they can, they'll grow right into your pipe and clog it up. So we want to prevent that. We create what we call a mulch shield. It's just creating an airspace around where the gray water comes out, and that way the gray water flows through the air, then it lands into the wood chips, the mulch, and then it soaks into the soil, and that prevents clogging. In this picture, you can see it's a little piece of 6-inch round piping, like a drain pipe. You can cut that into sections, drill a hole so the gray water enters it in the middle, so there's an air gap of several inches, and then it flows into the mulch. It's open on both ends. So you can put a lid, a cap, a paving stone, something where you can access that to monitor the system, and that's where you would do your annual maintenance. You can also use irrigation valve boxes. These are bigger and very sturdy. They have a built-in lid. That's a green cap that goes over them. The bottom is open, so the pipe goes in, you drill a hole, the gray water pipe goes into that irrigation valve box, flows through the air into the mulch. And then that green lid goes back on, and you open it to do your annual maintenance, to check on your system. And the water is flowing unobstructed through the air into the mulch. So you're running tubing, you're trenching, usually everything's buried. When you want to irrigate, you're just cutting into your tubing, and you're putting one of these barbed tees. So this is it's not an emitter, I call it an outlet. So you can see it's got a big opening. You can connect 1/2-inch tubing to it, and the water will flow through that. Oh, and this is a construction picture. When you're finished, it will all be buried. The outlets have to be covered by 2 inches minimum based on code. That will just keep the water below the ground and prevent pets accessing the water. The end of the line, this whole system is connected to your washing machine. So we don't want to do anything that could potentially cause extra effort or work or stress on your machine. And we always want to kind of carefully consider one place for where all the water can flow out unobstructed. This is often the end of the line, or it could be a special place where you do call it like an emergency overflow, but somewhere where the whole 1-inch tubing is open, unobstructed, all the water could flow out. And that way, if you ever forgot to do your maintenance, you didn't check on your system for a couple of years, the machine wouldn't be trying to push water through a clogged system. It would be able to send all that water out. And that kind of overflow picture, the picture on the right is showing you can kind of put this somewhere out of the way, hidden, maybe next to a porch or maybe up against a tree somewhere. Normally no water comes out of it, but if you ever one day saw water pouring out of that, you would know, oh, my system is clogged up. I'd better go do my maintenance and check on the system, but it wouldn't have stressed out your machine. Okay, so your system is built, you test it and you tune it. So you can temporarily disconnect the system and connect a garden hose into it to flush water through it. So you can check on everything. And then when you're done, you reconnect it. You want to balance your flows, make sure water's coming out evenly. Sometimes you need to adjust the angle of your tees. Sometimes you need to strategically add some ball valves. They're a special valve that's totally open in the middle. It doesn't restrict down to a small point like a regular ball valve does, but it can slightly restrict the flow to encourage the water to flow on to the next outlets. So sometimes you need 1 or 2 of those. You're always trying to avoid clogging by not putting in things that you don't really need. Like you don't want to put a lot of ball valves that you don't need. Make sure you're using the right pieces. Also doing your annual maintenance to check on your system. So at the end, you have some follow-up. You bury all your tubing, you check for leaks, you paint any exposed pipe. If you've come through the house, which you most likely have, you have to caulk the holes to make sure that no moisture or air can go through. You post your signs, you have a maintenance manual, and you get your Greywater friendly soap, and then you do laundry while you're watering your plants. It's really exciting. So that's just an example of a good construction grade sealant to seal up that hole so it'll stick on there and waterproof it. So we're getting to the end. I wanted to do a little design practice before we stop for questions to kind of, I gave you a lot, there's a lot of information and I know there's a lot to this. There's several calculations and then some considerations. So I want to go through a simplified design practice to help you think about how you could apply this in your own home. So here is a yard. It has a front loading machine. You can see there's a lawn in the middle and there's some fruit trees around the edge and a bamboo hedge in the back. And so first we need to gather some information about the site. So we need to know how much gray water. This machine does 15 gallons per load. The home does 4 loads a week. So they are working with 60 gallons per week of gray water. So that is the weekly flow. So now we need to decide, well, which of these plants can we water? So our next step is to calculate how much water do our plants need. So we just put them into that handy app, spits out some numbers. We found out the apple tree during peak week in July needs 24 gallons per week. So does the orange, the roses need 6. You can see on that, the zoom controls are covering up what the avocado needs, and the bamboo hedge needs 40 gallons per week. So now we make some decisions. So I always start with the closest plants because they're easiest to get to, minimize materials, start with what's close and suitable. So we'll start with that apple tree. So that needs 24 gallons. We have 60, so we have some more water. We can keep going. So let's pick up the orange tree. So now we're at 48 gallons. So we still have some more water. So we can pick up the roses. So now you can see we're getting to the maximum amount of water that we have. We're irrigating 4 plants. Sorry, some of these things, some of this is covered up on my screen. So I believe there's 4 plants. I can't quite see how many roses are over there. I think there's 2. So we have 4 plants. That's definitely within the range of that front loader. Remember, the front loaders are maybe 6 to 8 outlets. So here we could have 4 outlets. We have pretty much used up all of our water. We don't have enough water to take out the avocado tree or the bamboo hedge. That's a lot more water, but we are irrigating during the peak. So if this was my yard, I might say, well, I know I don't have to water this much all year long, so maybe I want to plant a couple of really low water use plants that can maybe be good for pollinators that are beautiful. And so I might add a couple of native drought tolerant, really low water use plants and maybe put them near to that apple tree or near the roses, and they could be irrigated also. So if there's a heat wave, I'm going to be out there with the hose and I'm going to water my trees a little bit more because I know that this system is not designed to accommodate a heat wave, but I know that most of the year it's totally suitable to keep my plants happy and healthy. And I'm maximizing the amount of water that I have. So that's the kind of thing that the kind of questions and decisions that you'll make as you design your system. So here's an example of a little sketch that this is kind of what you would do. It doesn't have to be beautiful, it just has to be, you want to be thinking about where you put the water. Here you can see the laundry is going out to irrigate a couple of kiwi, some raspberries, a couple of plants, and that's the kind of thing that you would do for your home. So about to the end, I just want to mention the maintenance and then some resources, and then we'll stop for questions. So once a year, actually more than once a year, every time you're doing laundry, you're right by the machine. So you will visually see if anything is leaking in your home from the valve, from the anti-siphon. And once you've gotten your system installed properly without leaks, usually this will not leak. Things will not leak. But of course you do want to check on things like you do anything in your home. So you'll notice them. So if you ever notice a leak, you can address it. But this typically doesn't require maintenance. The maintenance of the system is your basins. So you're using wood chips. It's a natural filter, works really well. It's taking what could be considered a waste product and it's turning it into a filter, plus you're building soil, adding organic matter. It's a really positive thing for your yard. But it's going to break down over time. You're adding moisture and a little bit of nutrients onto these wood chips. And so over time they'll decompose and they'll turn into really rich organic matter that's good to have, but it's not a good filter anymore. The water doesn't flow through it. So once a year you'll check, and if you open up that valve and you look down there and you don't see wood chips anymore, you see soil, it looks like soil, you will need to dig that out. You can put it around the base of your tree, put it somewhere you want it, and you'll have to put in fresh wood chips. And that's kind of replenishing your filter. Usually it's about using a trowel. It's like not very much work, but every 5 years or so, you might really need to get the shovel and kind of dig a bigger area and replace it. But you're not having to replace the entire basin each time. It's usually just right at the outlet. And maybe 5 years or so, you might need to do a little beyond the outlet. So the next thing that you need to do is check for clogs. So if you use any of those little ball valves, you'll need to check them for clogs. You can often disconnect your system, put a garden hose to it and flow water through it to kind of go out and check on everything, make sure it's flowing properly. I recently had a very confusing clog in my system where I couldn't figure out why the water wasn't reaching 2 of my trees at the end of the system. None of the outlets were clogged, couldn't figure out what was going on. I opened up the middle of the system and flushed water through it, and 2 giant slugs came out. They had gotten in the middle, like the main line of the Greywater system. I don't know how. They were much bigger than the outlets. And they had clogged up my system. So that was a learning experience, a new source of problems. But you do want to check and make sure that things are flowing as they should be. It's usually, I like to do it in the spring, kind of as you might have turned off your system for the winter if it's a rainy year, and you might turn it back on, but at least once a year, check on it. Materials. So there are some online suppliers. Waterwise Supply is an online place. You can buy a kit, get all the parts. You'll have to buy tubing locally. So you make sure you're using a 1-inch, a thick tubing. It's called high density polyethylene. There's a couple of brands, like Blue Lock is a brand. It kind of depends on what's available in your area, what you're going to use. Ewing Irrigation often has these parts. Though not always. You can check your local irrigation stores. I'm not sure in your area where would be the best bet for you, but probably your water district could help, or the city. And these are some books I wrote, the how-to books. So if you want to get a little more info, these were designed to help you go through the whole process. for the system, and they're available at the library and online as well and purchase. And just ending, this is the website for Greywater Action. We list people that have gone through our training, though they're not everywhere, but maybe you could find someone in your area if you're looking for an installer. We also have a forum where you can post technical questions, and then we have a lot of resources about Greywater. There's a manual you can download for free that has a lot of this info. There's just a whole bunch of information on there. And the very end, we do also do some online classes. So if you think I really want to learn more, want to get personalized support, we have a class coming up, Greywater Design Mastery, which is designed to help you kind of coach you through the whole process with live live Zoom calls to help people go through this whole process and create a really great design for their system. So I'm going to end there. And thank you for listening, and we'll see about questions, anything I talked about that wasn't clear, or if anything is coming up for you that I didn't address on your site.
All right. Thank you, Laura. And I know we have a couple of questions. I'll start with those ones that came in while you were doing your presentation. Dana had a couple of really great questions. She asked, can greywater go into a soaker hose, or would a filter be required?
Yeah, greywater will clog. It has lint and debris, so it would clog up a soaker hose right away. So it's not suitable. There are other systems that I didn't talk about today that do filter greywater. But even when you filter greywater, it can't go into any type of drip system or soaker hose that's designed for fresh, clean water, because even filtered greywater is dirtier than tap water. So if you're filtering greywater, you can use drip systems that are designed for wastewater, like septic effluent. There is specialized parts you can use, but it's not going to be like the parts you can buy at any typical store, or definitely not a soaker hose. Rainwater can go into that, but not greywater.
Great, good to know. And then she had another question. I think you kind of addressed this, but I kind of get it. She was asking, what do the actual outlets look like? And I know you kind of showed the different components in a couple spots, and I saw the barbed tees, but did any of your slides show where the actual water is going into your basin? Like, what is?
Yeah, so here you can see, this is like an almost finished basin, so you can see that black tubing coming in. So it's open. It's not like a drip emitter. It's just a full open 1/2 inch outlet. And then the basin will be filled to the top and covered. So you wouldn't quite see all of that. But that's what you see. I mentioned these ball valves, and so in this picture, you can see that you can add a ball valve to the end of that 1/2 inch line. And that's if you need to restrict the flow a little bit. On like a flat yard, you often need to put 1 or 2 in the beginning. Otherwise the water won't go to the ending outlets, but it attaches right there.
Got it. I found that a little confusing. I was thinking, it says to avoid ball valve. There's a ball valve there, but I get it. So yeah, just to restrict the flow a little bit if you need to. So it doesn't quite fill up too fast, or got it.
Yeah, and usually you might need 1 or 2. A common mistake that installers will do, or homeowners, is they'll put them on every single outlet just because, even though they don't all need them. And then you have a clogging potential on every outlet. And you also have room for user error. I mentioned the study earlier about water savings, but we also looked at plant health. And the only plant we found, looking at hundreds of plants, that was harmed by greywater was because the homeowner had put ball valves on all the outlets, or actually it was an installed system. So the homeowner didn't install it, but they, by accident, they didn't understand the valve. So they turned off every valve. So the entire load of laundry was going to the end of the line that was at an avocado tree in heavy clay soils. So it was getting totally oversaturated, and it started to show stress. And the homeowner saw, oh, my tree is stressed. And so what did they do? They watered it more. So this tree was just being drowned. And it was because it was because it was overwatered, but it was because there were ball valves on all of the outlets. So the homeowner was able to, because they didn't understand it, shut off everything but the very last one. So that's another reason you don't want to have them if you don't need them.
Got it. That totally makes sense. Do you have any recommendations? This is my question. Do you have any recommendations, because we do live in an area that we get freezing temperatures in the winter? And so we require that people winterize their irrigation systems and shut everything off. Or is that just a matter of doing the diversion? You just don't use that laundry landscape system in the winter, so none of the water's going out, and you already have in the system, obviously, that end of line or anything that is in there should be kind of already draining out at the ends.
Yeah, that's a great question. So I also live in, right now I live in Eugene, Oregon, where we get sometimes pretty hard freezes and snow and stuff, though not every year. So the first year, and this is my first time living in a freezing climate, I used an air compressor and I just blasted air through the system because I was worried about any, because you do have standing water. Most of it drains out, but there are points where there is like a little flat point or there could be standing water. So I blasted it all out, which wasn't too hard to do, but I did need to use an air compressor. And then the next year I'm like, the pipe is flexible. It's got a lot of play. Mostly all the water is drained. I don't really think I need to be doing this. And I haven't done it since, and it's been fine, no problems.
That's
So
good.
if you're worried about it, or maybe you use rigid pipe outside, if you use rigid pipe, then yes, you definitely should get all the water out. But if you're using this tubing, it expands and contracts, and it has most of the water is going to be gone. So there's room for some ice to form.
And I wanted to also mention to everybody in the chat, I messed up at first and posted the wrong document, but I did post a document that Laura shared with us, the Designing Your Own Laundry Landscape handout. So if you haven't gotten a chance yet, please be sure to open and download and save that. And then if you missed it or you're having a problem downloading that or anything, just let us know and we can send that to you. But it's a great handout that kind of walks you through a lot of those steps that she showed us today in terms of like sketching out your system, figuring out where things go, and calculating your water needs and calculating how much your landscape or how much your laundry is actually going to generate as well. Did anybody else have any questions? You're also welcome to raise your hand. If you want to raise your hand, we'll just go ahead and unmute you and you can ask your question out loud. Otherwise, you're still welcome to put it in the Q&A or in the chat panel. Give everybody just a couple of seconds. And while we do that, Laura did mention the fact that, for example, you can use rainwater in a soaker hose. We do have a free rain barrel program. If you are a Big Bear Lake Department of Water customer, you can contact us. We give away one per address. You can fill out an application that's also just available on our website and send that in. And then we have programs to retrofit your irrigation systems if you do have sprinklers for something like a lawn and you want to use WaterSmart or WaterSense certified irrigation sprinklers. We've got rebates for that, as well as the weather-based irrigation controllers and turf removal. She mentioned that as well. If you have a lot of grass that you don't actually use and you spend more time and money just having it maintained, mowed, that kind of thing, watered, then we do have a $1 per square foot turf removal program. You can just contact us. We can come out and measure that. Don't remove it and then call us. Call us first. Let us come out and measure it, see what you've got, let you know how much you'll get on your rebate first, and then you can remove it. I don't see any additional questions. I don't see anybody with a raised hand. Lauren, did you have anything to add? No? Okay. And Laura, did you have anything to add before we let everybody go today?
I was just wondering if you had local, like I use the Sacramento, the city of Sacramento as a kind of fill-in, but do you have local information if someone can just say, oh, I have an apple tree in the sun and it's this big, can you tell them how much water, or do you think that using that app is the easiest way?
Yeah, the app is probably pretty good. I'm glad that you actually mentioned that, because I was going to bring up evapotranspiration and then it was literally like 3 slides later because we do have really high evapotranspiration. I was going to ask you, maybe you do know this. Do you know if that calculator, is it literally just a deduction? So for example, if the ETO in July is 7.5 and the tree's needs are 14, is the assumption that you're just going to want to apply 7.5 plus 14 because of that transpiration, or do you know if the calculation is a bit more complicated than that?
It's the evapotranspiration, so it's what they need to be replaced.
Okay, yeah, so that's what I thought. So yeah, we don't have any specific local. I know there's like an IE, can't remember what the website is, like IE Waterwise or something like that, IE Water Smart, but it's for the Inland Empire and it generally focuses on the cities that are to the west of us, that are on between the coast and the mountains, so not our high elevation, so not quite the same transpiration rates that we've got up here. But they can always call us, we'll do the best we can. We aren't the absolute experts on plants and plant water needs, but otherwise talk to your landscaper. They're probably pretty knowledgeable. If you have a landscaper, do a little bit of research, go through the library. But yeah, we'll just certainly try to help as much as we possibly can. All right, it looks like we are wrapped up for the day. Again, if you think of a question later, just feel free to email us or call us and we'll do the best we can to get answered. And thank you, Laura, again, and we will see you again next month.
Okay, thanks.
All right, thanks everybody. Have a great day.